hey, look at this octagon. This is an octagon front. And the center line is right there in the center line of this ridge, as though they all came together, right? And I have it drawn right here, right? I'm going to talk about how to get this. I shot a video, a couple of videos on polygons, but you never really saw the wood of it. This is a 12-12 pitch. And you can see that there's common rafters, which are these rafters that emanate from the plate line at 90 degrees in plan view. That means looking down on it at 90 degrees. So here's one, so 1, 2, 3, 4, 5 here. And then the hip rafters come off the outside corners and fall in between and get nailed in between. And if you zoom in on this, I don't know if you can see that. That's the ridge, as though it were long, you know. That's a shorty there. 2 commons. And then here's the other commons, right? And then you can tell the hips because they have the long points on them. So everything has to be calculated to center line with this, so that you can draw this out and do your deductions and figure out how to get to the side of the rafter so that when you run the saws through, it'll actually end up at the point, right, of the cheek cut. So double cheek cut. So this is a long skinny cut. This is a shallower cut and so forth. So this has to be drawn out. But let's talk about how we do the math for this, right? It's a polygon. We talked about it before. 360 degrees circle divided by twice the number of sides, and then push second tangent on the calculator. Or if you're using a construction master, do what you guys do. But 360 degrees divided by, and twice the number of sides. And this is a octagon, so that would be 8 times 2 is 16 equals, and then I'll get 22.5 is the angle, the degree, right? 22.5. You see that? 0, 0, 0, 0, 0, 0. So that looks like this. Here is the plate right here. This is the continuous plate here. And I divided each side into 2 so that we can get the relationship between the hip and the common rafter, which is called the working angle. So this right here in plan view is the working angle, 22.5 degrees. On that same calculator, if you pushed second tangent, all right, 22.5, my bad, tangent, you'll get this ratio of the sides. Even though you don't know what the sides are yet, you get the ratio of the common rafter run to the short little leg here, right? And this would be the short one, right? Obviously because it's less than 12 or less than 1. So if I multiply that by 12, which would be the run of a common rafter, 4, 12, 5, 12, 6, 12, and so on, times 12, I'll get the length of the short leg, which is 4.9. See that right here? This leg. If this was 12 inches, this would be 4.9, right? And if I wanted to get this hypotenuse, I would say 4.9 squared plus 12 squared. The answer would be the square root of whatever this length is. So let's do it. 4.9 squared plus 12 squared equals, and then push the square root of, and that's 7.988 or 7.99. I'm sorry, 12.988 or 12.99, which we call 13. This is 13 inches here, right? And so that's plan view, but we have to add the corresponding rises to this. Now this is the hip rafter, this rafter here in plan view for every 12 inches of common rafter run. So that's neat because we just have to get increments of 12, but rather than do that, we want increments of inches. So what we'll do is, first thing we'll do is go a squared plus b squared equals c squared to get that one, and then add your corresponding rise. So this is going to be, let's say this is a 12-12, but right here is a mock-up of a 6-12. So here's the miter ruler that we were just looking at, right? Here's the common rafter of a 6-12 pitch roof that sets right there on the common rafter run here. And here's the hip rafter, which is an elongated rafter, but with the equal rise like this, so they meet each other. That's a common and a hip rafter, right? Both of them have a 6-inch rise for every 12 inches of common rafter run, and a travel of the hip at 12.999 or 13. We just call it 13, but accuracy is better like that, right? So what we want to know is this length, which is the length of the actual hip, not in plan view like this one, but the hip rafter. So we can divide it by 12 and get inches, because this would be feet and inches, and that'll be the line length ratio, or the secant of the rafter. So we're going to add 6 inches of rise to them. So we already have this length here, right? 13. So we're going to go squared plus 6 squared equals, and then the square root of, and that's 14.30. You see that? So this length right here is 14.30 if measured with the tape measure or with the square. 14.30. And then that's 14.30 is 1 foot 2, right? 0.30, 3/8 shy. So, but we want to put it in inches, so we divide by 12 equals, and we get 1.192. For a 6/12 pitch roof, that's the hip rafter secant, or line length ratio, for an octagon. And then you calculate outside of plate to outside of plate, and don't do any deductions, and then divide it in half. So don't subtract for the ridge, out to out, and then just divide it in half without subtracting the ridge, and that'll give you to the center line mark. And you multiply your hip rafter by that number, and that'll give you the length of the hip, an imaginary length all the way up here, and then you draw this out with your square, 22.5 degrees, 45, 90, like that, to center line. These are 22.5 degrees, these are 45 degrees, right? Twice that, right? To center line, and then do your deductions in plan view, because all deductions are in plan view at perpendicular to the plumb cuts.